Hi everyone, in this video I will discuss about amino acids and proteins, which is a part of syllabus of BSc third semester general chemistry. So now we look at what are amino acids and proteins. I think this is not that new for you because you have already studied about amino acids right from 11th standard, even about proteins, which are very much well known for all of you. We will see what are structure of amino acids. As you already know, the structure from the term what it says, it is amino acid, that means it contains amino group and acid group. So this is the general structure of amino acids. Any chain with amine and COOH in the same molecule can be called as amino acids. So these are some of the examples of amino acids. So you can see there are some non-polar, polar groups and various chains. It may be sides, chain may be branched, or it may be a normal unbranched chain, or with aromatic, or with something else like sulfur group, or it may be some extra CO group, like that. I mean, it goes on. So now we will come to the classification of amino acids, how amino acids are classified. See, if you go through the various sources available or different types of books, there are various ways in which amino acids are classified. One such way is based on chemical properties. I mean, what kind of properties it exhibits chemically. So you can see that one with a non-polar side chain, that is non-polar amino acid. Some are with a polar, aromatic, positively charged, negatively charged amino acid. So we will see one by one discussing examples like glycine, alanine, why they are called polar amino acids, why they are called non-polar. Non-polar, the terms indicates that it does not have any the resultant polarity, that is why they are non-polar. If you see the structure of amino acids, so you know the concept of zwitter ion, it exists as NH3 plus and CO minus. So it is a kind of minus and plus which is neutralized almost. So it is a kind of zwitter ion structure most of the amino acids have. So if there is no extra polar group, then it comes under non-polar. Then if you have, it has some resultant polar group, then it will be polar. Then aromatic, if the side chain has some aromatic group, and positively charged if the resultant amino acid is having something positively, and negatively charged if it is having negative resultant charge. Now based on nutritional requirement also you can classify amino acids like essential amino acids, non-essential amino acid. Some of course fall in between, that is semi-essential amino acids like histidine. So in most of these resources, if you see the books, histidine and arginine fall under essential amino acids, especially histidine. So there are basically 9 essential amino acids. So isoleucine, leucine, lysine, methionine, like that. Even histidine also you can include here. There are several non-essential amino acids. I hope you know the difference between essential and non-essential amino acids. Essential amino acids are those which cannot be synthesized by the body. So it has to be supplied from the external source. That is why it is called essential, the term, it is required. So non-essential, partially it can be synthesized by the body, but some are supplied from external sources also. So that is why they are called non-essential, or sometimes it may not be needed for the body for certain reasons. And there is another way of classifying is like hydrophilic and hydrophobic. I hope you know the term. Hydrophilic means which loves solvent, which is polar, that is water loving. Hydrophobic means which repels water. So based on side chain, what kind of side chain is attached, it can be classified as hydrophilic and hydrophobic. So under that again hydrophilic, you have negatively charged, positively charged, and some are uncharged. And again hydrophobic, we have aliphatic side chain and aromatic side chain. So this is how they are classified. So coming to the structure, if you see, I mean under the classification only, so amino acids with some electrically charged side chain, which I already told you. So some are having the resultant charge. You can see there are some extra amino group or COOH group, then there will be a resultant charge. Otherwise, if there is only one COOH group and one NH2 group, then it is almost a kind of neutral because it exists as a zwitter ion. So coming to this structure, like with the polar uncharged side chain, if you see it here, so it has one COH and NH2 group. That's why it is almost a zwitterion, but it's not charged, but it has polar side chain like OH OH. This is again polar, and side chain is polar. So going ahead, so it can also be classified as neutral amino acid, acidic amino acids, and basic amino acids based on the structure. So any one you can remember if it is asked in the examination. So you can just write as essential amino acids, semi-essential, non-essential amino acids, or non-polar amino acids, polar, aromatic, positively charged, negatively charged, that's also fine. Or easiest way is you can call the classification as neutral, acidic, and basic, and other. That's also fine. This is bit easy to remember for your reference from the examination point of view. So amino acids, neutral amino acid means it doesn't have extra COH and NH2 group. So it's easy to understand. So you can see the number of COH group and NH2 group are equal here. So they are neutral. So even if it is there something in extra, you can see this NH2 group is there, but this is an amide. Most of the amides either they are basic or neutral. So this is amide, this is not an amine. So look at the structures carefully. See, most of these structures have equal number of NH2 and COH group. So it may be here, or it may be here, one amino and one COH group. Then what happens? It will be neutral, almost neutral. So, but there may be side chain which is having other groups, polar or non-polar, or here you can see there are amide groups, still they are almost neutral. So examples like glycine, alanine, isoleucine, and you have interesting example that is proline, very good organocatalyst, and there are examples like tryptophan and glutamine, etc. And some are acidic amino acids. Acidic amino acids like best examples are like aspartic acid and glutamic acid. You can see the structure here, it has one extra CO group, nothing but COH. So if it is having one extra COH group, then it falls under acidic. So basic, so lysine, histidine, and arginine. So basic amino acids, they have one extra NH2 group. So one COH and NH2 here and one other NH2 here. It's protonated because it abstract proton because of basic character. So you can see one extra amine group everywhere. Okay. So this is because of that it falls under basic category. And other amino acids which we cannot classify like acidic and basic. So these are some of the examples like ornithine, hydroxyproline. There are several hydroxyproline, OH here, here, and all. So they all come under this category. Okay, this is all about classification of amino acids. Going ahead, the peptides. What are peptides? The peptide bond is simply a CONH bond. So how it is formed? The bond CONH is formed by the condensation of COOH of one amino acid with NH2 of another amino acid. A simple reaction by the elimination of water, you will get CONH bond. But remember, peptide bond synthesis, though it looks easy, it is not that straightforward. You can't just mix one amino acid with other amino acid with some coupling agent. You can't just make CONH. This removal of water is not that easy the way it is written here, because you can't just synthesize peptide bond by just mixing these two amino acids. So what we have to do, we have to follow some steps. That's why we need some protecting groups for amines and acids. So there are different types of protecting groups. What are the protecting groups? From the term you understand, protecting groups are nothing but they protect. So they protect certain groups to avoid some unwanted reactions, or it may be some side reactions. So it takes care of unwanted reactions and it protects certain groups at certain stage and allows the further reaction to go ahead. So from the definition, what do you understand? These are the groups which protect amine part or the acid part in order to carry out the reactions efficiently, and it can be removed after the reactions. If you want to see N protecting groups, see in the syllabus there are separate N protecting and C protecting groups. N protecting group, here it is nothing but protecting group used for NH2 or NH, amino protecting groups. Not only N, I mean don't misunderstand with the term. So, N protecting is nothing but protecting groups used for amino groups. So, these are the groups which protect amine part and makes the other reaction, other part of the reactions at the molecule will be facile after protecting NH2 or NH, and at the end this can be removed without disturbing or without interfering with the other parts of the molecule. The best examples is Bock anhydride, of course, you can see the structure. So, it is tertiary butyl group and it is a carbonate group at the center. So, anhydride it is, so you can easily break with the presence of water or dilute HCl, and you have benzyl chloroformate, it is called CBZ chloride, CBZ chloride, and acetyl chloride CH3COCl, you have tosyl chloride and methane sulfonyl chloride. Again there are various examples, these are some of the examples which you can remember from the examination point of view. Then you have protecting groups for COOH. So, C protecting means what here? It is protecting groups for acids, COOH protecting groups. Again why we are protecting? Because again COOH being a labile group or very much reactive, so it causes intervention, it makes intervention during the reaction of the other part. That is why COOH group has to be protected in order to carry out the reaction at the other part of the molecule. So, remember there are various protecting groups for COOH also, but very commonly used in peptide synthesis are acetyl chloride, some alcohols, because you can make esters and you can easily remove by simple hydrolysis, and you can easily make acetyl here and then you can remove it by hydrolysis, and some other groups can be used, but removal is bit difficult. You can see how peptide can be synthesized by making use of these protecting groups and how it can be efficiently converted to some peptide bond formation. You can see formation of CONH here. So, this is a general peptide synthesis scheme. You have, you are taking amino acid wherein COOH group is protected, NH2 group is NH2 group is outside here projecting. This whatever these lobes, what you can see here, they indicate the protecting groups. At the end of the reaction, see the last product which you have amide, so it does not have any lobe here, that means protecting groups are removed. So, please note this point. So, in the beginning you take one amino acid and you protect COOH part of it and NH2 part is available. You take another amino acid wherein NH part is protected, so PG indicates protecting group. So, these lobes can be protecting groups or it is simply something wherein amine is attached to it. You must have heard about the polymer, some polymers with NH2 is also fine, but you can consider this as protecting group or as a polymer, or you can simply say NH2 is solid supported, it is supported over something which may be a polymer or some solid support. So, or I consider this as a protecting group, simple, it is very easy to understand for you at this stage. So, if you consider these lobes as protecting groups, again another protecting group for NH. So, remember before carrying out the reaction, both suppose you have two amino acids, I will explain it in the next example. You have two amino acids, one amino acid COOH has to be protected and NH2 should be free. In the other amino acids, COOH should be free and NH should be protected. So, now in one amino acid NH2 is free, in another amino acid COOH are free. Now, you have to couple this to get CONH bond. Okay. Now, you start the reaction, you have coupled with this. So, you have the formation of CONH bond, both the protecting groups available on the same molecule. Now, deprotection of this, correct, you have deprotected it and then you couple with another amino acids where it is protected. So, at this stage now from this reaction what do you understand? So, this lobe is something polymer supported. So, how you started the reaction now? Polymer supported this NH2, now it is reacted with one amino acid to give CONH bond. Now, you have deprotected this part. Now, in this case NH2 is now available Now with this NH2 you couple with another amino acid COH of this, and wherein NH is protected here. See here, now in this molecule NH2 is available for coupling, and in this molecule NH is protected and COH is available for coupling. We have done the coupling reaction. Coupling is nothing but simply the combination of or removal of water and formation of the CONH bond. So you have prepared this amide, and now you do the deprotection of this. At the end you do the cleavage of this polymer support or something which is supporting NH. So remove this, so you will get amide. So this is an amide formation. Okay, this is how peptide synthesis is done in general. In your syllabus there are only two examples to be discussed, that is synthesis of gly-ala. It is nothing but glycine and alanine. So you have made a peptide bond by coupling glycine and alanine. So how will you do this? You have to start with glycine and alanine. You have to couple and form a bond for glycine and alanine, that is CONH bond between these two. Okay. So you start with this. So you have one side we have alanine part, another side we have glycine part. Okay. In this example you can see it here. So glycine and alanine. So you have alanine part. So that is nothing but CO, this one NH, this CH3, and RCONH. You can call RCONH CH3CO part, and from the glycine part you have NHCH2COCH3. Where is the amide bond? CONH. This is the amide bond formed between these two. Okay. Now you start from alanine, that is NH2 CH3, correct, and COOH. So that is NH2, that is CH3 COOH. Okay, this is alanine. You started with alanine. Alanine you have to protect either COH and NH2, and again here in the glycine you have to protect either COH or NH2. If you are protecting NH here, then you have to protect COH here, because for coupling reaction using DCC, DCC is a coupling reagent. Structure of DCC is which is a dicyclohexyl carbodiamide. You have dicyclohexyl group and carbodiamide group in between. So then the CONH you will get urea derivative as the end product, which can be easily removed by column. You can also use EDCI. So EDCI is having this structure. It is a modified reagent of DCC. The advantage of using EDCI, it is a salt, is over DCC is this goes in water after the workup. So when you do workup after the amide bond formation, you just add water or dilute HCl, then it easily goes out in water. So you get the end product bit clean. Okay. So how this coupling is carried out? So you can start with glycine or you can start with alanine, whichever is okay. So if you see it here, you started with alanine. Alanine NH is protected. It is converted to amide group, that is CONH. You reacted with RCOZ, RCOCl or whatever, or RCOBr, whatever it can be. So you will get NHCOR. Now this NH2, whichever is reactive, has become unreactive now, because it is amide. You know, amides are not that reactive or very less reactive compared to amine. So now this is this group you made very stable. You converted labile group into stable group. Now COH projecting from this molecule is available for coupling. Now you take the glycine. In glycine what you have to do? You have to protect COH. So how will you do it? The best way to protect COH is convert acid to ester and keep the amine part intact. So you have converted acid to ester. How did you do this? You react with the methanol in the presence of some acid, or you react with ethanol, any alcohol, but it should be easily be removed at the end of the reaction. So you have carried out this reaction, and then you maintain the pH higher to in order to keep this basic, okay. Just you have neutralized this acid. See, note down this because these are some of the important steps in the practical chemistry. Here you have maintained the pH lower than 7 at the end of the reaction during the workup. Why? Because you have to generate this acidic group. See the step, initially you reacted with RCOCl, that whatever the side product HCl or something comes out will be making this acidic and will be making this protic, okay, protonated. That time pH goes higher because you have it is neutralized by some base because you have to add some base here. So, NHCO it is converted to, then you converted the molecule into acid instead of keeping it in CO minus. So, you have acidified the solution. So, convert this into COH. So, that COH should be available for this coupling reaction. Here you increase the pH in order to make this amino group available. That means you have made it basic. Okay. Now, look at these two groups, protected alanine and glycine. In protected alanine, so you have COOH and C protected glycine, you have NH2 group. So, this is N protected alanine, this is C protected glycine. Hope the terms are clear for you because N protected means what? It is NH2, that is NH2 part of this alanine is protected. That C protected glycine means what? COH part of this is protected. That is what I had stated in the beginning. So, you have now NH2 and COH open for the coupling. You added DCC in the presence of dichloromethane and some base like you can add some tertiary amine base like pyridine or triethylamine, and the reactions you have carried out to give the coupling reaction. The coupling is nothing but formation of amide bond between this NH2 and this COH. Mechanism is out of syllabus, that is why I am not discussing it here, but in brief I am explaining that is formation of this amide bond. So, once you got this amide bond, now the next job is to remove your protecting groups, that is RCO part and ester part here. Okay. So, you remove it by some acidic or basic condition. So, this you can hydrolyze by base, this you can do it by acid, but make sure that time this part is not removed, okay, this part is not hydrolyzed. So, you will get alanine and glycine. You can see in examples in detail, you have glycine react with Bock anhydride, okay. This is the best example to illustrate how exactly you will get glycine alanine for amide bond formation. Glycine you have protected NH2 with Bock anhydride, so NH Bock. Now, you convert this into COCl, okay. Now, what you do? Next you can add alanine to this. This is also called acid chloride method. Acid chloride method you can call it as, because you are using acid, you are converting acid into chloride, that is why it is acid chloride method. Acid chloride method. So, it is bit facile compared to the earlier one which you have seen here. So, you are just converting amine into acid chloride, but protected acid chloride. Then you add the alanine. So, glycine you have taken and converted to acid chloride, protected acid chloride of glycine, then you add alanine. So, now alanine which part will couple? NH2 will couple with this COH. See, this remains intact because there cannot be bonding between this and this. Even if it happens, OH attacks, then you know again it goes back. So, NH2 which is more nucleophilic will attack here, not the COH-OH part. Okay. So, you will get CONH bond, then what you do? Just hydrolyze this NH Bock, remove the Bock using trifluoroacetic acid, you will get glycine alanine. So, if you think in an examination this is bit complicated, that is using DCC coupling and removing using some other groups. So, you can remember this acid chloride method which is very facile and bit eco-friendly because the side products are all going in water here. all the side products what you see, SOCl2 will be converted to HCl and sulfur dioxide. Sulfur dioxide will go out and HCl will go in water, and you add base again, that will go in water, and trifluoroacetic acid again can be removed by some basic alkali solutions or by just by water. So, you will get amide out. This may be water soluble sometime, but by repeated treatment with some solvent, so you can you will be able to extract it in organic solvent. Okay. And another synthesis is you have synthesis of glycine. So, the same method you can apply here. You have taken glycine, converted to NH Boc glycine, okay, amine protected here, Boc protected amine. Now, you convert this COH part to COCl, then you add another mole of glycine to this. Now, CONH bond is formed, remove this Boc part, so you will get glycine. So, how will you do the reaction? In an RB or round bottom flask, you take glycine, add DCM Boc anhydride, make sure it is dry, do not add water, and Boc anhydride you take this in dichloromethane, and triethylamine you add 0 to RT you can maintain, because Boc anhydride when you add it is a bit exothermic. Then you slowly add Boc anhydride from the top in the form of solution, because Boc anhydride is solid compound. You have to make a solution in DCM, or you can directly add the solid, but make sure while opening and adding, because it is bit exothermic, make sure you have maintained the temperature 0 to 0 degree Celsius. Then you keep it for 15 to 20 minutes, bring it to room temperature. You have this, do the workup just by washing with sodium bicarbonate, dilute solution of sodium bicarbonate, you get this. Take out this and react with thionyl chloride. You add thionyl chloride, you can take this in DCM or just like that also you can take, add thionyl chloride. You will get acid chloride. That acid chloride you keep it in the same flask, keep it in the same flask, do not remove that, because most of the side products or gases here go out. You can just concentrate and keep it in the same flask, remove the solvent and keep it in the same flask. Add glycine, you can add a solution of glycine, or in the solid peptide synthesis you have to add another amine in the presence of some coupling agent, that is a different topic. I do not discuss it here. So, you add glycine, then the coupling reaction takes place in the presence of some solvent. So, at the end you add TFA to the same solution, stir it for 15 to 20 minutes, you will get glycine, just do some basic washing, so you get rid of TFA. So, whatever the solid comes out, you will be lucky if you get this in the form of solid. So, then you just do some acid base purification, so you will get this compound. Okay. This is how you do the synthesis of glycine. You do not have to remember the practical part from the examination point of view, you just remember how the scheme is performed. Just take glycine, convert it to Boc protected glycine, then you react with thionyl chloride, you will get acid chloride, then you add glycine. CONH bond, once it is formed, you react with TFA or dilute HCl to get rid of Boc. Okay. Then coming to the next topic, that is proteins. So, what are proteins? So, proteins are nothing but it is a macromolecule consisting of one or more long chains of amino acid residue. So, it is a macromolecule, it is an amino acid you know already, and peptide bonds you know. If it contains several peptide bonds, branched or chain, so then you can call it as proteins. Hope we all know the term macromolecule, the meaning of the term macromolecule, polymer type molecule, correct, which is having molecular weight very high molecular weight. So, there are different types of proteins, I mean there are structurally which are different, like primary structure, one with a secondary quaternary structure, different type, but anyway that will be out of syllabus, so I do not discuss all those. So, basically as per the syllabus you just have to know proteins, what are the different types of proteins, how they are classified. So, types of proteins based on functional properties, it is mentioned in the syllabus. Functional properties means what kind of properties they exhibit based on their function, what kind of work it is going to perform. Functional group, it is not functional group, it is functional properties, what kind of work it is going to perform in the body, that is called functional properties. So, what kind of work it can perform, like it can act as antibodies, right, like you There are various types of antibodies which are generated in the body in order to fight against various diseases. It can be immunoglobulin, so one such examples. You have another type is contractile proteins like actin and myosin, and enzymes, you know, all enzymes are proteins, but not reverse is true 100%, but all enzymes are proteins, but not all proteins are enzymes. So, you know, different types of enzymes which are used generated in the body for various hydrolysis purpose, breaking down various molecules. So, they are enzymes. For enzymes, one such functional, I mean they exhibit various functions, they do various functions, that is why it comes under functional proteins. And you have hormonal proteins. There are different hormones which are proteins like growth hormone, insulin, and you have structural proteins which are responsible for the structure of our muscles, or it can be some organs. It can be like keratin of skin or and hair, and collagen of connective tissues. And you have storage proteins, various proteins responsible for storing the various fats, or it can be lipids, right, albumins, globulins, prolamins. And you have transport proteins like myoglobin and hemoglobin, you know, this carries oxygen throughout the blood. So, these are different types of proteins classified on the basis of functional properties. There are various ways you can classify protein, but as per the syllabus you have to classify based on functional properties. So, then coming to protein denaturation, what do you mean by denaturation? It is something which is not normal, so it is totally abnormal, or the protein, whatever that initial or the primary property is lost completely. So, you can see denaturation process in which proteins or nucleic acid lose the quaternary structure, tertiary structure and secondary structure which is present in the native state. So, they lose the native state property or the structure. How can you do it? By application of external stress or using some acid, concentrated acid, or some concentrated base or something like that. So, protein loses its property. Okay, you can see that you have the coiled protein which is called a folded protein. It has lost its structure after denaturation, either by applying pressure or heat, or using some strong solvent like chloroform, or some concentrated concentrated acids. So, you can do the denaturation. So, these are the different ways in which protein will lose its property. It may be biological, chemical, whatever the property, or structural property, completely it will be lost. So, these are the different ways, like heat, you apply heat, you heat it to high temperature, change in pH, make it either acid or a strong alkaline, ultraviolet rays, X-rays, or high salt concentration and heavy metals. I think this is very much known for all of us, because heavy metals, what they do, or salt, they just bind with the proteins, they make complex with the proteins. That is what happens in the color formation of the proteins. You know, it changes its color by making complex with certain heavy metals, and you know that is how heavy metals like mercury and some metals like arsenic, they are all very much poisonous, we call it as. Why? Because they make complex with proteins and totally disrupt the structure of proteins and properties of protein. That is how protein will lose its authenticity, and the person will doom at the end. So, this is what happens. So, you can see the change in temperature, pH, salt concentration, all these things are responsible for the denaturation of protein. It is a serious problem of concern, of course, because denaturation of protein is nothing but denaturation of our body, right. When we take some toxic metal, it will start making complex with the proteins present in the body, and it will destruct the part by part. This is what can happen, the consequences of denaturation of protein. So, now we have several tests for proteins. So, one by one we will discuss. There are various tests available in your syllabus. Only there are 3 tests: Biret test, Ninhydrin test and Millen's test. So, Biret test, I think very simple one. You just take the protein sample. Protein sample can be the white part of the egg, which when you take in a test tube, add a few drops of NaOH, shake it and add copper sulphate, very dilute solution of copper sulphate, shake it, and you will get violet color. Okay, formation of this violet color will indicate the presence of proteins in the sample. So what is the reaction taking place? Any protein you take, it contains amide bond, you know. This amide bond is going to make copper complex. Okay, this the copper complex is violet in color. You know, the color of copper solution, we know it is blue in color. So here you may misunderstand that when you add drop by drop this blue solution of copper sulphate, you may think that a protein is present, but blue color is because of copper sulphate, not because of protein. You should get deep violet color. If you do not get immediately, you can slightly heat it, so that you know the formation of copper complex, or you can slightly cool it sometime, copper complex will be favored. So you will get this copper complex, this kind of complex based on different amino acids. So this complex will be responsible for the violet coloration. Then you have ninhydrin test using ninhydrin reagent. So here you get again a kind of purple color, it is not violet now, bluish purple. Sometimes you won't be see proper purple, it will be kind of bluish compound formation. So what you do, you add ninhydrin drop by drop to protein solution and heat it, boil it, and then you can cool it. Then during the time of boiling only you will start seeing the formation of this bluish purple color. Okay, this indicates the presence of alpha amino acids. This is not answered by all proteins. The proteins which have alpha amino acid or alpha amino acid itself will show this bluish purple color. So what is ninhydrin reagent? It is 2,2-dihydroxyindane 1,3-dione. It is basically a indane molecule. Okay, CO here you can see CO, this ninhydrin orange colored crystals you will get. So you can directly add that in water and add protein, or make a solution and keep it. So this exists in the form of diol and keto. So because of this structure. So what happens when you add proteins or amino acid, especially alpha amino acid, it will form this kind of complex or this kind of conjugated compound which is responsible for its purple color. So with the elimination of carbon dioxide, other amino acids apart from alpha amino acids won't give this complex, because the removal of carbon dioxide will be difficult. So this complex is answered, or it is formed only by the compounds which have alpha amino acids. Okay, this is what you find. Please note this point, proline will give kind of yellow orange product, it won't give violet or blue color complex, sorry, purple or blue color complex, it gives a kind of orange coloration. So no amino acid, if there is no alpha amino acid, then you do not get test, you will be having slightly orange or you know kind of colorless you will get after boiling. So but purple or bluish to purple you will get if the amino acid is present, alpha amino acid is present. If proline is present, proline is again an alpha amino acid, you will get yellow orange product. Hope this test is clear. And then going further, you have Millen's test. Millen's test is just addition of Millen's reagent, then you heat it. It is answered by only those compound having tyrosine. The proteins which have, note this point, it is answered by tyrosine proteins or amino acids. So when you take this amino acids, so make sure, I mean when you have these 2-3 steps, make sure what they indicate, what they confirm. So this confirms the presence of alpha amino acid, that is ninhydrin test, and Biret test is mostly common for all amino acids and amides, I mean basically for all the proteins. So even urea is also answering this test very commonly, and this is mainly for tyrosine compound. So you have reagent and then you add Millen's reagent, I mean the compound plus Millen's reagent, mercuric sulphate plus HNO3 is Millen's reagent, then you heat it. If you get red pink color, then amino acid, that is tyrosine is present. If you have red pink color, then proteins containing tyrosine. See, note this, it is answered by amino acid which is tyrosine or the proteins which has tyrosine in that molecule. Okay. Basically for tyrosine it is. In both these cases you will get red pink color. You can see the Millen's positive test, presence of tyrosine. You can see the reaction here. Tyrosine, when you react with mercuric nitrate and nitric acid, so it forms mercuric nitrate. This is the proposed structure, but as I get for the possible formation of brick red product or whatever that coloration kind of brick red or slightly red color you get, this may be because of this whatever he has proposed with the spectroscopic evidence. Okay, these are all about 3 tests for proteins. So, these are some of the references. You can read the specified books for organic, the general books for organic chemistry, wherein you find proteins and amino acid, books like Morrison and Boyde and Finar, and there are various very good books. Ball and Wall you can read, but limited it is contained. Okay, then there are various e-learning materials like NPTEL classes, Khan Academy and EG Pathshala, and please go through them to attain better knowledge. Thank you for watching.